All right, welcome. I'm going to do a video here on linear independence and determinants. Okay, let me just move this out of the way here. All right, and so basically what I want to talk about is this idea. So we have a set of vectors v1 through vm. Okay, let's say in n-dimensional space. Which we call Rn. All this R means is that we're just taking all these real numbers. Okay? We could do it in complex space too, but we're not going to do that here. Okay? A set of vectors is called linearly independent, linearly independent if C1 V1 all the way up to Cm Vm equals 0 is equivalent to C1 equals C2, and all of these equaling 0. Okay? Likewise, a set of vectors V1 through Vm is called linearly dependent if C1 V1 plus Cm Vm equals 0 has a solution, and we call it non-trivial solution. Okay. Let's just get into a couple examples. So let's take, as an example, let's take 1, 1, 0. Let's call that V1. V2, let's take that to be 0, 1, 0. And then V3, let's take that to be 1, 3, 0. Okay, so these are going to actually be linearly dependent. Okay, linearly dependent because I could take V1, I should have put arrows on here, V1 plus 2v2 minus v3 equals 0. Okay, if I do that, then I'm going to get 0. So I get solutions with these three added together that are, with these three, or combinations of these, that where the constants are not 0. Okay, so let's take that in contrast. Let's take V1 equals, let's keep that 1, 1, 0. V2, let's even keep that 0, 1, 0. And then V3, let's make that, instead of 1, 3, 0, let's just make that 1, 0, 3. Okay, so now let's try and solve the sum of, or the linear combination of these three equaling 0. C1 V1 plus C2 V2 plus C3 V3 equaling 0. That's going to mean, let's see, first row is going to be C1 plus C3 equals 0. Second row is going to be C1 plus C2 equals 0. And then the third row is going to be 3C3 equals 0. Okay? So now, if I try to solve this system, then I'm actually going to end up getting that C1, C2, and C3 all have to equal 0. Okay? So these three vectors are linearly independent. All right? Okay, so I know I normally do one video for one page, but I'm going to go ahead and go to the next page, because the idea, or the thing I want you to understand, is if we are given n vectors in Rn, okay, let's call them V1 through V sub n. I know my names are so original. Okay, then if they are linearly independent, then the determinant of the vector made up of the columns being these vectors. You could also do this with the rows, it's the same thing, is not equal to 0. Okay? And linearly dependent, okay, then the columns given by the rows, as you might guess, if it's linearly dependent, that equals 0. Okay? All right, I'll see you guys in the next video.